A child of weight 330 newtons is at point X at top of the slide. The slide is at the edge of the swimming pool as shown in the figure, as you can see, and the child moves from rest to the lowest point of the slide, that is vertical distance of 4 meters below X. As you can see, he's going to slide down and cover this 4 meters of distance. The child continues moving towards point Y, which is at the end of the slide, and a vertical distance of 1.1 meters above this lowest point. The kinetic energy of the child is specified at Y, which is 540 joules. So when he reaches this point Y, that's when he has a kinetic energy that is associated with the motion, 540 joules. Calculate the difference in the gravitational potential energy of the child at point X and Y. So we want to figure out how much of the gravitational potential energy has changed when he moves from point X to point Y, right? And so we know that the change in gravitational potential energy is given by mg delta h, right? Where delta h is the change in height. Now, in this case, m and g, which would both be constant, so the mass of the child was 330. If you go back, the weight of the child is 330 newtons. So in place of mg, I can replace with 330 newtons because that's the weight, and then delta h. So delta h would be the change in height. Now he reaches finally at point Y, which is 1.1 meters of a distance, while initial distance was 4 meters from the same reference point. This is our reference point, right? And from here we are measuring our distances. So this is 1.1 meters finally, and the initial distance was 4.0 meters. So this gives us minus 957 joules. Now this negative sign has a meaning, and this negative sign is telling you that there is loss in gravitational potential energy, which would make sense because initially he's at some height, and having some height is associated to having some potential energy. Now that potential energy has to be lost and being converted into kinetic energy. So that's why the person initially even started moving, and so therefore the loss in gravitational potential energy is minus 957 joules. However, the difference in the gravitational potential energy is the absolute of this thing, which would be 957 joules. Next part, an average frictional force of 52 newtons act on the child when moving from X to Y, right? So when he's moving from X to Y, obviously there should be some frictional force acting on it as he's sliding across this thing, and that frictional force is given as 52 newtons. By considering changes of energy, determine the distance moved by the child from X to Y. So we want to figure out how much distance does he covers as he travels from X to Y. Now here we can use the principle of conservation of energy. So the conservation of energy tells you that the potential energy at this point X should be equal to the kinetic energy at this point Y plus the potential energy at Y, because it's still at some distance from this reference point. And of course, then there is some work done against the friction as well. So you would add that work done against the friction as well. So this gives me an equation that says that the potential energy at X is equal to the kinetic energy at Y plus the potential energy at Y plus the work done against the frictional force. Now potential energy at X would be mg and the distance at X. So mg is 330 newtons and the position at X is 4.0 meters. Now the kinetic energy at Y is specified in the question. It was 540 joules, this one. Now we have to add the potential energy at Y. So again 330, which is the weight, times the height, that is 1.1 meters. And finally the work done due to friction, which should be the frictional force. If you remember, work done is given by the force times the distance moved in the direction of that frictional force. So because this is the distance that is moved in the direction of the frictional force, this would give me the distance moved by the child from x to y, because that's where the frictional force is acting. So it's 52 newtons times d. And now you just rearrange this expression for d to solve. This becomes 52d is equal to 417 newtons, and this gives me d as 8.02 meters. So that distance moved from x to y is 8.02 meters. Part C says that the child leaves the slide at point y with a velocity that is at an angle 41 degrees to the horizontal. The path of the child through the air is shown in this figure, as you can see. So he jumps off the slide. This is the angle of its velocity vector from the horizontal as 41 degrees. This is the path of the child. He travels in this trajectory, and here we have the surface of the water. Point Z is at the highest point on the path of the child through the air. So this is when he has maximum height from the horizontal. Right. Assume the air resistance is negligible. Calculate the speed of the child at point Y. So what would be his speed when he is at point Y, just about to move off from the slide? Well, we remember we have its kinetic energy at Y as 540 joules, right? So if you remember, the kinetic energy at Y was 540 joules. Now, we know that kinetic energy is also equal to half mv squared, which means I can equate this to 540 joules at point Y, and this would give me a relation for V as 2 times 540 joules divided by m square root. So if you do the math, m would just be 330 divided by 9.81, right? So I'll write it over here, 330 divided by 9.81, because weight is 330 and g is 9.81. So if you rearrange this, w equals mg, this gives me mass as weight divided by g. Now, if you do the math, this gives you the velocity of 5.67 meters per second. So he leaves the slide at point Y with a velocity of 5.67 meters per second. So his initial velocity after it leaves the point Y was 5.67 meters per second. How about at point Z? What would be his speed when he is at point Z? When he's at point Z, the only velocity that he has is the horizontal velocity, because that's the maximum height where his initial velocity, vertical velocity goes to 0, because the direction changes, right? The direction of its path changes, which means that the only velocity he'll be having is the horizontal component of velocity at point Y. So we can figure that horizontal component of velocity at point Y because we have 41 degrees angle as well. So we know that the horizontal velocity component is given as v cos theta with the horizontal. Now we know our v is 5.67, the velocity with which he left the cliff, the slide, and we have times cos theta, which is 41 degrees. And this gives you 4.28 meters per second. So his velocity at point Z, which is the maximum height that he attains, is 4.28 meters per second.